Hi everyone, and welcome to the final in our webinar series, Connection Regardless of Location. This session will focus on coverage extension. My name is Sam Dilley, and your speaker today will be Moti Shalev, one of our product managers here at Axel Wireless. We've got a very interesting webinar today, but before we get started, I just have a couple of housekeeping points. During the webinar, you'll be placed on mute to avoid any feedback and to ensure we finish on time today. If you have any questions for Moti, please send them via the chat option, which you should see on your right-hand side of your screen, and we'll get through as many as we can at the end of the webinar. Okay, over to you, Moti.
Hello everybody, I'm happy to be here with you again. Our topic for today will be a very interesting webinar regarding coverage, extension coverage. We'll have a short introduction about Axel Wireless, then why we need the coverage extension, multiple solutions that are available to solve this problem, and a very interesting case study of a project done by Axel Wireless in Malé, the capital of Maldives Islands. And of course, we leave some time for Q&A. So Axel Wireless has been in this industry for the last 40 years. That's a very, very long time. We are a global developer and manufacturer of DAS, Distributed Antenna System solution. 1.5 years ago, we became a part of Cobham, a private listed company traded in the London Stock Exchange. It's a very big technology giant with revenue of $3 billion per year. And the main reason for this transaction was due to the quality and technological innovations of Axel Wireless. We have customers all over the world, over 150 countries, selling to more than 170 mobile operators and multiple offices all over the world. In the latest ABI report, and ABI, this is a worldwide analyst company covering this in-building solution, Axel Wireless became #1 in innovation. Of course, we're very proud about that. This is basically due to the latest development that we've launched half a year ago, a new platform launched in a Mobile World Congress show in Barcelona for intelligent digital DAS. So that's put the Axel number 1 in innovation, and overall globally #3. Again, need to remember that when they do this overall revenue, they take into account any cables, antenna, etc., any third party, which in Axel case we don't sell them, so that's why we're only #3. But again, we're very proud about this report. Why we need the coverage expansion? So again, everybody, whenever we leave, they want to make sure that they have a very, very good coverage and have very good connection with their mobile devices. Sometimes in remote areas or rural areas, it will be very hard or sometimes even impractical to put base stations, and think about if that's a very small village far away from anywhere, like in the middle of nowhere, and we have some places all over the world that we have such rural areas, it becomes uneconomical to put a base station. Sometimes even, to get the power, electricity to feed the base station, it's becoming a very big challenge. So again, that's another problem. Of course, we all know that we need, when we have base station and any basic equipment, we need to feed it, so we need the power. And of course, no matter about the cellular coverage, for sure, we need to make sure that emergency services for police, fire, EMS, they will be available. It doesn't matter if that's a rural area or downtown big city. So if we take a look from a different perspective, from, let's say, from the resident or the landowner, of course, if I'm the customer, I want to make sure that whenever I get access to all the voice calls, text, emails, internet without any interruption. And of course, if I'm visiting a place, let's say a resort or something like that, I also want to make sure that I have a very good coverage there, and want to make sure that it's very safe and secure. If something happens, the emergency services, first responders will be able to come very quickly to this area. If I am the mobile operator, of course, I want to make sure that I get a higher customer satisfaction. If my competitor will have coverage in a certain location and as an operator I will not have, maybe some customers will leave this operator and move to the other one. And again, thinking about places where you have a lot of roaming customers or visitors, overseas visitors, again, that could be a very good potential to increase the revenue for the mobile operator. Let's take a look now of a different solution that we have for a coverage extension. There are basically three main technologies. One of them is Offair. We'll explain what it is. Offair BDAs or repeaters. We have in Axel a very unique solution called TCOS. TCOS stands for Tetra Coverage Optimization Solution. Again, we'll touch base about that. That's mainly for public safety Tetra solutions. Again, unique solution. And of course, we have the outdoor DAS solution. Again, we'll touch base on all these examples. So if we are looking on off-air solution, basically an off-air BDA, bidirectional amplifier, picks up the signal using a donor antenna to pick up the signal from the base station. And again, another antenna or more to service antenna, basically it does the BDA does, we are using in all our solutions, digital, patented digital DSP-based filtering, very, very sharp, very good filtering. And basically the BDA does all the filtering and of course amplification of the signal. And then basically all the RF is retransmitted into the designated and required area. Again, when normally you install these coverage extension solution for the off-air, you need to make sure that you have a relatively high gain BDAs. Why this is required? Because sometimes you will find out that the signal coming to this location is very weak. So you need a lot of gain to overcome the distance basically from the base station and the donor antenna. And again, as we all know, it becomes a big challenge in off-air. That's a standard phenomenon in any off-air solution that if you have a very high gain, then it's a potential of oscillation of the BDA. In Axel, we've developed some unique techniques to avoid this oscillation. But again, it needs to be done a very, very good RF design to make sure that the distance, the type of antennas that you put, the distance between the antenna on the pole itself, if it's one pole, or sometimes you can use multiple poles to help you to increase basically the isolation between the donor and the service. But again, to put a number, normally in this let's say most of the vendors use these numbers of around the 15 dB above the gain. So basically the max you measure the isolation between service and donor antenna, and then basically subtract 15 dB, and that's the maximum gain that you can achieve from that off-air solution. So again, it can work in some instances. Again, need to do a good RF design. If we now have a solution of this really, really unique solution of a TCOS, Tetra cost coverage optimization solution, basically just a reminder how a standard Tetra base station works. So again, a Tetra base station will normally cover a very limited area. Again, depends on the topology, and if that's a hilly terrain, of course, it would be cell radius of 10 kilometers or even less. In many cases, it's uplink limited, and then normally, and that's a sort of a unique requirement when we're talking about public safety, not necessarily cellular. Basically, the big issue in a public safety application, like in Tetra application, that we want to make sure that we have coverage. It's not sometimes not as much channels or as much capacity that is required today nowadays in a cellular application like LTE and HTTPS, which everything is about capacity. When we're talking about public safety still yet, with the current technologies of Tetra or P25, it's mainly the coverage. In the future when it moves to LTE, so that needs to be changed as well. Let's take a look of a standard architecture of a Tetra, and that's basically You take Tetra base station, put them in the area middle of the area that you want to cover, and in this example, we have multiple base stations, five base stations that covers this area. Again, when we take a look about this solution, we can see that this is a relatively expensive solution because remember, the cost of the Tetra base station is very expensive, and also not only the CAPEX, but also the OPEX, the backhaul OPEX are very, very expensive as well. Sometimes you need to use either fiber optic or microwave links for this backhaul, and that's monthly fees that you need to pay. Again, if you now want to look from the operation perspective, if you want to make basically a group call with all these users within this area, basically it's a problem because each one of them uses different channels, so that's a big problem. So again, such a solution gives you some limitations. So what is basically the alternative offered by Axial Wires? And that's really, really unique solution that we have. The idea here, and that's basically a slide that explains this architecture, is doing what we call frequency translation. What does it mean? If we take an example on this slide that you can see, we have a Tetra base station that is providing coverage on the 400 on the UHF band on F1. So basically, if we want to extend this coverage, so what we are doing, we are basically using a BDA or a repeater to translate the frequency, basically to get F1 in, and the output of this repeater is F5. And this is used as the link frequency now, not the coverage frequency. And on the other side, we do the opposite. We get into the repeater F5 and translating back again to F1. Again, we're using our patented DSP technology to do all these filtering, again, to make sure that you have very sharp, very good filtering. But if you think about it, when we're using this architecture, basically you avoid all these problems that we have with isolation. So between the antennas, because when you have two frequencies, isolation is not an issue at all. Okay, so how now the solution will look like? Basically, instead of 5 base stations, we can use only 1. And in each one of the locations, we'll use this pair of 2 repeaters to do this frequency translating. So basically, we save a lot of cost on this architecture, only 1 base station instead of 5, and we don't need to worry now about all this problem with backhaul, and again, all these oscillation problems that we've mentioned before does not exist at all. The biggest issue, and that's why I want to highlight that, and that's exactly why this is a solution that is uniquely for Tetra. We all know the big challenges that we face within Tetra systems. When we're talking about Tetra solutions, the delay, the maximum delay between the direct signal and, let's say, reflected signal, or or dual path signal, that's basically should not exceed about 14 microseconds, because otherwise, basically, the handset will not be able to lock on the signal. So again, if you think about the architecture that I showed before, it's now, no matter how many repeaters we have, and remember that we have now 2, we need to make sure that the overall delay of the filters will be lower than that, and Axial developed the state-of-the-art filters of they using in these 2 frequency translating repeaters to make sure that the delay is lower than 14. It's around 6 microseconds per repeater, so you're talking about overall 12 microseconds, which again meets all the requirements by Tetra, and that basically allows you to work. And again, if you're familiar with designing of DSP filters, believe me, that's a real art to do such a filtering. Another solution that is typical in these remote areas is using what is called outdoor DAS solution, or ODAS. And again, DAS stands for Distributed Antenna System. The idea here is to take the signal, the RF signal, convert it to light basically, use fiber optic technology, and then can go up to 20 kilometers to remote location. Then we have a remote unit that does the conversion again. In this architecture, normally what we are using what is called base station hotel architecture. What does it mean? This means basically that we are co-locating multiple base stations of multiple technologies of all the operators in one location. Think about that now from a maintenance point of view. It becomes much easier to access one location. If something happened to the base station, it's easy to access. You go to one room. You have only one room that you need to take care of electricity, air conditioning, etc. And again, so it reduced a lot of the OPEX and CAPEX expansion. And from this room, basically, you will do this, take this optical master unit that we've seen in the previous slide, basically this OMU, which will be connected to the, normally it's co-located within the base station hotel. And this will be the unit that Axel Wireless provides to do the RF to fiber optic conversion. And from there, the fiber optic and remote unit that does the conversion back again to RF. So again, this is being used. This is a very good solution that is being used for remote areas coverage. Sometimes also this is a concept that is being used for very big infrastructures in building dust, like big airports or big stadiums where you have a lot of capacity required. Normally, in many cases, you use this BTS hotel concept. So if we take a look of the major benefits of this outdoor dust solution, again, if you think about this, when we have these kind of technologies, and today, as I mentioned before, everything is about having a lot of bands, a lot of capacity. That's the buzzword, when we are moving to LTE and HSPA+, it's all about capacity. So normally, in many cases, you will need multi-band, multi-technology solution. And if we take an example, and it's an example that we can find from many places all over the world, let's say that I have 4 operators with 4 bands. Guess what? You have now 16 services that you need to cover. So 16 services can all be supported through a single remote unit. And if you want to take a look on the alternative will be to use a, let's say, remote radio heads architecture. Then you'll need probably 16 remote radio heads to address the same issue. So think about that, how much more expensive and space it takes. Here we can have only one remote unit that can do it. Convection cooling, again, very important, from maintenance point of view. So you don't need to worry about the fans will break or something will happen. So again, and of course, IP65, you need to install it outdoors. So without IP65, that's no go, basically. And a very important thing, and that's again something really unique to Axel Wireless, is very low power consumption. We put a lot of effort in our design to minimize the power consumption. Why this is important? If you think about that, a very simple thing is electricity bills all over the world are going up every day, unfortunately. So we need to pay much more for our electricity bill. So again, if my system consumes less power than the competitor, I will save a lot of money. And in some cases, I was surprised myself when I did some analysis with some of our competitors that Axel Wireless in some of the cases were around 30% of the competitors without mentioning the name. So again, that's really significant. And also, sometimes in this remote location, guess what, as I mentioned before, they don't have this electricity to feed the remote unit. So sometimes they use the technology taking power from solar sources. And again, of course, these solar sources are limited, so you want to make sure that the power consumption of your remote unit is as low as possible. And this is just an example of our remote management. Everything is using a modern web-based management, and again, of course, using standard technologies like SNMP to report alarms, and we have a higher level of network management system that basically supervise and monitor a complete fleet of a DAS solution, fiber optic DAS, and Offair solution. Okay, now let's take a look on a project that we did in Male, the capital of Maldives Islands. So what was the challenge in this project? In this project, the biggest challenge was that this is not a very big island, but again, very, very narrow streets with, very dense built environment. So guess what? This is not very good for RF coverage. And basically, they didn't have a good coverage inside the street themselves. So again, the requirement was to provide, at that time, 2G and 3G services for the operators in Maldives. And again, they didn't want now to put, of course, alternative. We put a lot of base stations, and solve this issue. But again, they didn't want to do that. So what they did, basically, they've used this concept that I've mentioned before, this using a fiber optic DAS solution with base station hotels. So basically, they had one or two locations within the island where they co-locate all the base stations with all the services. And from these locations, they pull up fiber optic cables and goes all the way to remote units that were installed on poles on the street and provide basically coverage within the street. So again, remember that that's a picture of such a remote unit, relatively compact unit, again IP65, convection cooling, multi-band, multi-technology. So of course, one unit like that can support all the technologies and all the operators. And that basically provided a solution in this island, in this the capital of Maldives. Again, of course, this provided a good solution, 2G and 3G. At that time, they are now, by the way, looking to upgrade that for 4G services as well. For residents and visitors, again, this is they have a lot of resorts in this island, so guess what, the operators can make a lot of money if they have good coverage from visitors that are coming to vacations in the island. So, and they've used in this project the Axel Wireless Element Manager. This is called AEM. This is our basically network management platform that provide monitoring and supervision for all the elements installed in the project. And again, very, very important when you install or design such solution that it will be a future-proof solution. The last thing that you want to happen, when a new technology comes, or additional thing, you need now to take everything out and redo the project again. Again, remember that the units are already installed. So in our designs, and that's basically in Axel Wireless, all products that basically we sell, we're using very, very linear amplifiers that, again, doesn't matter if that's 2G, 3G, or 4G, will work without any issue. So for example, when they now moving to 4G, basically from our perspective, they don't need to do any changes. They of course need to bring the base station for the 4G, but again, from our perspective, they need to do nothing, which again, if you think about that, saves a lot of hassles and of course a lot of money. So this is now a very good time to go to questions and answers.
Thank you, Motti, and thank you everyone for listening. We've had some great questions come in, so I'll get on to them. The first one I have is, how is it possible to support multi-band, multi-operator in one remote unit?
Okay, again, this is when you look on the technologies, it's becoming a very challenging thing sometimes. And again, it depends on the frequencies. If you have some conflicting frequencies, meaning that you have some frequencies that are very close to each other, like something that we have in APAC in some of the region, 850 from US and 900 from Europe. Sometimes you need a dedicated filtering to do that. So you need, it starts with a very good design, RF design of the unit. Again, make sure, again, very, very important, when you have multiple bands, you need to make sure that you have very, very good and unfortunately sometimes very big and heavy duplexers that will do a very good job with the rejection and make sure that mitigate all the interference between the different bands. And also, as I've mentioned before, when you're talking about multiple technologies within the same band, again, without having a MCPA technology with a very linear amplifiers. I don't see how this can be done. So basically, that's the technology that we are using in our units.
That's great. Thank you, Moti. Right, the next question I have is, what is the typical coverage distance for the TCOS system?
Okay, so it really depends on the topology or geographical location where you install the system. But if we take, let's say, we stick with this example that I've showed with this slide, you know, if you think about that, you know, each one Tetra base station can cover around, let's say, 10 radius of 10 kilometers. So now if you take this ratio of 1 to 5, basically we are talking about having a radius of 50, close to 50 kilometers to be covered by this TCOS solution. Again, needs to do a very, very good RF design. Everything starts with, as I always say, a successful project starts with a very good RF design. That's everything. Whatever you have the best product, if the design is not that good, it unfortunately sometimes will not help. So, but that should be typical numbers. Again, if you have any specific project, we're happy to discuss it with you.
That's great. Thank you, Moti. Okay, I think we'll leave it there for now. If you do have any further questions for Moti, please don't hesitate to contact him. His details are in front of you on the screen. Thank you everyone for joining us, and we hope you can join us in our future webinars. Goodbye.
Thank you very much. Bye-bye.